So you guys, I thought I recorded that whole video already, but it turns out I didn't. So now I'm re-recording it. And you can see my face, which we haven't done before, but here I am. Anyways, lecture 6.4, acids and bases. I just did this whole thing, and now I'm doing it again, thanks to technology. Failing, or maybe it's me failing to use it right. Anyways, I've talked too much. Before we begin, grab your science notebook, title a new section, lecture 6.4, acids and bases. Make sure you update your table of contents. Set up your notes in Cornell. Grab a highlighter to highlight key terms. You know, the usual. Let's get started. Today's lab was all about acids and bases. So first we're going to go over acids, then over bases, and then a little bit more about pH and what that means. But as you can see in these pictures, we got some acids. We got Coca-Cola, which we tested today, and we found out it is an acid. We've got lemon, and we know that the juice from a lemon is an acid. We got stomach acid, which we know we have, and also vinegar, which is an acid, acetic acid. So what is an acid? An acid is any liquid or chemical that, when poured into water, it will release hydrogen ions. Like, that's the technical definition of an acid. If you squeeze lemon juice into water, it will release hydrogen ions, little hydrogen atoms that are positively charged. Okay? But what are the properties or the characteristics of acids? Number one, sour taste. Sour taste. Now, the reason why Coca-Cola, even though it's acidic, doesn't taste sour, you probably guess because there's so much sugar and sweetener added over that, so you don't taste the acid. But with the lemon, yeah, you taste the acid. With vinegar, you taste that sour taste. And also, acids, when they react with metal, they release a gas. They release hydrogen gas. How are they used? How are acids used? Number one, they help your body digest food. We all have acid in our stomach to help us digest food. We wouldn't be able to digest if we did not have that acid. Some people who have low acid, they actually have to take acid pills, little pills filled with hydrochloric acid in order for their stomach to be able to digest food. So it's very important that we have the right amount of acid in our stomachs. And also, acids make up proteins. Protein, which we're going to talk about actually in a few days. But our skin, our hair, these are all made up of molecules called proteins, and those molecules are actually made up of amino acids, which we'll go over later. But acids make up proteins, and they're also important in the diet. Vitamin C, which you know is a very important vitamin for your immune system to keep you healthy. Vitamin C is actually called ascorbic acid. That's its technical name. Okay, that's acids. Let's move on to bases. Remember, if you ever have to pause to write stuff down, go ahead and pause it. I'm just going to keep going at this speed. Bases, as you can see in these pictures, we got laundry detergent, we've got dish soap, we've got Clorox, and some Rolaids and Tums, and these are all considered to be bases. So the definition of base is anything that will release hydroxide ions in water. So, So if we put any of these into water, they would release hydroxide ions, which are OH, and a little negative sign. What are the properties of bases? The characteristics. Number one, they feel slippery on the skin. They do, as obviously you felt soap before, very slippery on the skin. And acids have a sour taste. Bases have a bitter taste. And bitter, if you've ever got any soap into your mouth ever in your life, you know what I mean. Like, that's bitterness. It's really awful. So it's different from sweet or sour or salty. It's bitter. It's just, you know what I mean. How are bases used? Well, obviously, we got some cleaning products, but also you can use a base to help soothe pain from stomach acid. So sometimes with digestion, there's like too much acid going on. Sometimes you get what's called acid reflux, and you got acid coming up here. You get the heartburn in your chest. It's because of the acid, so you need to take something that will balance out that acid. And if you look real closely under the Rolaids, it says antacid, which basically means anti-acid. So if you've got a lot of acid, you need to add a little base to balance it out. So that's what these Tums and Rolaids are for. I know, I've definitely taken plenty of those before. And also for cleaning soap. Bases are good for that. Alright, now for the pH scale. pH The pH scale is a numerical scale that shows how acidic or basic a solution is. So the scale goes from 0 to 14, and it shows you how acidic or basic a solution is. Another word for basic is alkaline. You may have seen this, you may have heard of it. Well, something that's really popular right now is alkaline water. Normal water has a pH of 7, but now they're making water, or water is being made that actually is a higher pH than 7, and this is supposed to balance out your body's acids. That's the claim, and bring wonderful health and all that. I don't know if it's been tested, but alkaline water, I've heard of it before, maybe you have. Goes from 0 to 14, the pH scale, as you can see here. So anything that's below 7, so remember 7 is like right in the middle, that's neutral. Anything that's below that, like a smaller number, that would be considered an acid. Anything that's above that would be considered a base. And right at 7, we would call that neutral. So if you look over here, here's some examples of solutions that fall into different areas on the pH scale. So we got pure water at 7. Rainwater is a little bit acidic, acid rain. So it's here about 5.5. Then we get to vinegar, Coca-Cola, stomach acid. These are very strong acids. Then we get to battery acid. If you ever had a battery that somehow, I don't know, like got punctured and some of the acid came out, you do not want to touch that. That will burn your skin. So anyway, those are the acids, and over here we got the bases like ammonia, household cleaner, baking soda. These things are on this side of the scale because they're bases. And lastly, how do we measure pH? Well, that's what we did in our lab. We used various pH indicators because they indicate to us what the pH is, or they indicate whether something is an acid or a base. So pH can be measured by using indicators. What we have used in class, we've used pH paper, that's what we used, to actually find out the different pH levels of all those different substances that we tested. You dip the pH paper into the substance, it turns a color, you match the color to the color chart, bam, you've got pH. We know exactly what it is, and then from there we know if it's an acid or a base based on that scale from 0 to 14. And we've also used something called litmus paper, which comes in 2 colors, red and blue. Blue litmus paper, which is here, you can see a person holding a blue litmus paper. So you take the litmus paper and you dip it into a solution. If it stays blue, it's still a base, or it is a base. If it actually turns red or pink, that means that that solution or that chemical is an acid. And it's just the opposite for the red litmus paper, which a person is holding here. You get the red litmus paper, which is really pink. It's not like red, but that's what it's called, red litmus paper. And if you dip that into a solution, if it stayed red or pink, then it's an acid. But if it turns blue like this, that means that solution is a base. And then also we've used this phenol red liquid, and oh sorry, this W got cut off there. But it will turn yellow when there's an acid present. As we saw in one of the labs that we did in the bag, the exothermic lab that got really hot or warm, that liquid went in red, but after the reaction happened, it turned yellow because an acid was produced. So that's pretty much it. That's acids, bases, and pH. That's it, guys. So we will stop right